Hi guys, good night everybody. Just let me know if you guys can hear me before we start, please. All right, guys. So today was supposed to be session 7, right? And based on the schedule, I was gonna do um, investigation type questions today, right? However, I've gotten lots of requests regarding vectors and matrices, right? So I've decided to make a little switch, right? So this might be a little beneficial for some of you all who have trouble with this particular topic, right? So let's jump into it right away, right? So the focus today will be on question 10, which is vectors and matrices, right? Just remember you have no choice in the exam paper. We have to do all 10 questions. Vectors and matrices only go to this question if you are comfortable with this question, right? Try to focus on the questions that you are comfortable with first, right? And then if you have time, you're going to do this last, right? Don't rush to do vectors and matrices first at all, right? Um, all right, so just some reminders here, guys, right? So these are the online classes that I do offer, right? My new sessions will be starting at the beginning of August 2024, right? So that's a new Form 4 class for new students entering Form 4, right? As a reminder, guys, remember to hit like and subscribe, right? And you can always feel free to share the YouTube channel, right? I've done tons of videos over the past 10 years, right? So please feel free to share to anyone that needs help, right? So let's start with this first examination question here, right? So this is from January 2013, and let's see what we have here. The diagram, not drawn to scale, it shows a parallelogram OKLM, where O is the origin, S is on KM, such that MS is equal to 2SK, right? And they're telling us that OK is equal to V and OM is equal to U, right? Now, don't get too scared when you see questions like this, right? Don't be too scared. Like I always tell my online class, right? When it comes to vectors, I want you to think of a vector as moving from one point to another, right? And depending on what they ask us in the question, you are essentially driving from one location to the next, right? Once you understand that is what it is, the question becomes very easy, right? So they gave us only two vectors here. They gave us vector OM and it's given by U, and the vector OK is given by V. Now, what I want you to pay attention to is this here. We have a point S that is on the line MK, right? And they're telling us that MS is twice the length of SK. So whenever you see a statement like that, what you're going to do, you're going to divide that line MK into how many parts? Does anybody know how many parts should I divide the line MK into? How many parts should I divide the line MK into based on the information they gave me there? They said MS is 2 times SK. So that line MK, how many parts am I going to divide it into? Right? So I've seen some answers in the chat there. A lot of people telling me 3. Right? So those of you not sure how to do this question here, that's the first thing you need to do. Divide this line into 3 equal parts. And that is because based on this statement here, MS is 2 times SK, right? So, all right. So we want to work out the first part, which is MK, right? So before you can work out MK, you need to write down what is the vector equation to find MK. So MK, right? Again, think of this as driving from one location to the next. So you're here, this is M, this is K. So if I want to go from M to K, I can go this way. I can go from M to O and then O to K, right? That's one possible route I can take, and that's the route I'm going to take. So MK is equal to MO plus OK, right? So that's my route that I'm going to take here. Now the vector MO, right? Now they told us in the question that OM, right? OM is equal to U, right? Anytime you want a vector in the opposite direction, so if you want MO, right, all you need to do is to put a minus sign in front of the vector. So therefore MO is going to be minus U. So therefore this here is going to be minus U plus the vector OK, right? And OK, according to the diagram there, is V, right? So that's the answer for MK, right? And they consider it so simple, they only give you 1 mark for that, right? So MK is simply going to be minus U plus V. The next thing we want to work out here, we want to work out the vector SL, right? So you want to go this way, right? So again, right, you want to start at S and you want to end up at L. So what you need to do is to look at the diagram carefully and you need to determine how can I move from S to L, right? Based on that position there are multiple ways I can go from S to L. I can go from S to M, and then I can go from M to L. That's a possibility. Or I can go from S to K, and then I can go from K to M, right? Now in questions where we have a parallelogram, right, there are certain things we need to write on the diagram one time. So if you know OM is equal to U, it means that KL, that's this vector here, is also equal to U. If OK is equal to V, it also means that this vector here is also equal to V. So whenever you have a parallelogram, try to write in those vectors one time, right? That's going to help you. Now, let's see what we need to do now. All right, so I want to figure out the vector SL, right? So for me, this is the route I would want to take. I can say here what? SL is equal to SK, right, plus KL, right? Now from the diagram, I already know what KL is, but I don't know what SK is, right? But remember, you divided up the line MK into 3 equal parts. So SK, right? Now in part 1, you already worked out MK. So therefore, if I want to get this little vector here, SK is actually 1/3 of the full vector MK, right? Because remember, you divided up the line MK into 3 equal parts. So SK is only 1/3 of it, plus KL. So at this stage, it's just a matter of substituting into the vectors into this equation here. So this is going to be 1/3, and MK is minus U plus V, right, plus KL, which is equal to U, right? So now you need to remove your brackets here. So this is going to be minus 1/3 U plus 1/3 V plus U, right? And what you need to do here, guys, you need to simplify. And the best way to do this, right, and I suggest that you all use a calculator for this part here, because a lot of students, they have trouble with the fractions. Let me use your calculator and see if you get any answer that I have here. What I'm going to do, I'm going to take minus 1/3 and I'm going to add it to 1. So on the calculator, minus 1/3 plus 1, I'm going to get 2/3. So therefore, this here is going to be 2/3 U plus 1/3 V, right? So that is my vector SL. I hope that makes some kind of sense, right? I hope so. Right, so that's my vector SL here, right? So that's part 2. The third part now, we want to work out the vector OS, right? So the vector OS is this vector here. So this is O, and this is S here, right? That's S. Control that a little better, right? Now, to get OS there, right, again, you have 2 options. If I want to go from O to S, I can go from O to M, and then M to S. That's a possibility, right? Or you can go from O to K and then K to S, right? That's another option there, right? It's totally up to you. It doesn't matter which one you take. You're going to get the same answer either way, right? So let me just get a a blank slide here. All right, so according to the diagram, if I want to get OS, I can go from S to K and then K to S, or I can go from O to M and then M to S. So I'm going to do OS, right? I'm going to take this route instead, OM to MS. Right? Look at the diagram carefully. So if I want to go from O to S, I want to take this vector here. I'm going from O to M, and then I'm going to go from M to S, right? Now I already know the vector OM, that is equal to U, and the vector MS is going to be 2/3 of MK, right? So this here is going to be OM plus 2/3 MK, right? So OM, according to the diagram here, is going to be U. So this is U plus 2/3 the vector MK. We worked out MK before, right? MK was minus U plus V, right? So this is going to be U minus 2/3 U, right? Plus 2/3 V, right? So again, 1 minus 2/3 will give me 1/3. So this is going to be 1/3 U plus 2/3 V. Right? Now, a word of advice here, guys. When you all work in these vector questions, try to work them as fractions. Try not to work in decimals at all. Right? Don't work in decimals, please. Right? So, so I've seen a lot of people saying that they saw me impressed today, right? I was not impressed today. I don't know who you guys saw in presentation, right? Right. So I was not impressed today. So I have an impersonator out there or something, right? Right. So those of you who those of you who are talking about the vector question here, guys. If you guys have to do a vector question, the diagram is very, very important, right? The diagram is very, very important, right? So whenever you have to do a vector question, right, try to draw a diagram as best as you can, right? Try to draw a diagram as best as you can, right? Right, people asking about pure maths. No, I won't be doing a pure maths session, right? All right, so that takes care of MK, SL, and OS, right? Remember the video is being recorded, so you can go back to the video if you need to, right? It's being recorded. So this one is a pretty simple vector question so far, right? Let's have a look at this one here now, this part B. So we have a matrix, right? So remember, we can use a matrix in transformations. So we have a matrix given by 0, minus 1, 1, 0, and it represents a single transformation. The image of the point P under this transformation is 5, 4, right? The image of the point P under this transformation is 5, 4. Determine the coordinates of P, right? Determine the coordinates of P. Now, we can use a matrix in order to perform a particular transformation, right? Now, in this case here, what you need to understand is that, let me see how best I could explain this to you all, right? Now, we don't know, in this question here, we know what the matrix is, right? It's given by this figure here, right? 0, minus 1, 1, 0. But you have to read the question carefully. They said the image of the point P is this. This is your image, right? And they want you to determine what are the coordinates of P. So what I want you to understand is this. You have a point P. We don't know what the coordinates of this point P is, right? Now P undergoes a transformation, and normally our convention is this. We call this P prime. And our image, they told us in the question here, is 5, 4, right? So this here is 5, 4. That's the image after the transformation. Now this transformation here is given by something called G, and G is given by 0 minus 1, 1, 0. That's the matrix, right? So G is equal to 0 minus 1, 1, 0. That's your matrix, right? So what we would normally do if we have to perform a transformation on a point, we will normally take the matrix, which in this case is 0 minus 1, 1, 0, and you would have taken that matrix and you would have multiplied it by your original point or your object point, which in this case we're going to call xy. We don't know what it is, right? But it's xy. And that there is going to equal to our image point, which in this case is going to be 5, 4, right? So what we need to do, we need to figure out what is x and what is y. So what we're going to do, we're going to do a matrix multiplication here, right? So those of you who don't know, right, or forgot, whenever you're multiplying two matrices, it's always row multiplied by column. That's what we always multiply. So when we multiply that row by that column, we're going to get 0 by x will give me 0, right? And then minus 1 by y will give me minus y. So on top here, this is going to be minus y, right? So that's the top of the matrix, right? That's going to be minus y. And the next one here now, we're going to take this row and we're going to multiply by this column here, right? So 1 by x will give me x, 0 by y will give me 0. So therefore, this here is going to be x. And that is equal to 5, 4. Since these two matrices are equal, we can say that minus y is equal to 5. So therefore, y is equal to minus 5. And we can also say that x is equal to 4. So just like that, we know what the coordinates of P is going to be. It is actually 4 minus 5, right? Now, when it comes to these matrix questions here, we have to read it carefully, right? Right? So like I said, for those of you who have trouble with vectors, right, do a search on my YouTube channel, right? I did a vectors class a while back, right? A live session, right? If you go through that video, I guarantee you will understand how to do vectors, right? Just do a search and you will be able to do vectors, right? All right, so that is for... Right, so that's part B here, right? That's part B we took care of here now. Now, part C now, we want to write down the matrix H, right? Want to write down matrix H would represent an enlargement of scale factor 3, right? So we can use a matrix in order to represent an enlargement, right? A 2 by 2 matrix, that is, right? So all you need to do here for that one, right? Because the scale factor is 3 here, right? This matrix that they want H, right, is simply given by, right, it's going to be 3, 0, 0, 3. That's all you need to do. So when it's an enlargement, it's going to be 3, 0, 0, 3, right? So for whatever enlargement, once you want to write an enlargement and you know the scale factor, it is always going to be K, which is the scale factor, 0, 0, K, right? So the 2 by 2 matrix to represent an enlargement of scale factor K, right, about the origin is given by this matrix here. So since it told us the scale factor is 3, this is going to be the answer for C part 1, right? Now, in part 2 here, and they like to bring this as well in the exam, determine the coordinates of the point 5 minus 7 under the combined transformation H followed by G. Now, for this particular question here, you have to look at the order in which you're performing the transformation, right? When they tell you H followed by J, it means that H is being done first, right? And then J is being applied to it, right? So that affects how we're going to work this out, right? That affects how we're going to work this out. Now, what I would tend to do for a question like this, I would find my combined transformation first, right? That is what I would do. I would find my combined transformation. So here's how I would work this problem. So since I said H followed by G, right? H followed by G, right? It means that H is taking place first and then J is taking place after. So what I would do, I would find the matrix product GH, right? That is what I would do. I would find the matrix product GH, right? So here's what I'm going to do here. That's all. I need some more blank pages here. So J, right? J was 0 minus 1, 1, 0. Right? And H was given by 3, 0, 0K or 0, 3. Right? So that is my two matrices here. Right? So in the question it said H followed by G. Right? So what we're going to do, we're going to work out the product JH. That's what I would do first, right? So JH is equal to 0 minus 1, 1, 0, and you're multiplying that by 3, 0, 0, 3, right? So again, to work this out here, right, you're going to get a 2 by 2 matrix as your answer. But we're going to work out row by column, right? Row by column. So you're going to take this row, first of all, and multiply by this column here. So 0 by 3 is 0, right? And then minus 1 by 0 is going to give me 0. So therefore, this here is going to be 0. Then we're going to take this row here, right? And then we're going to multiply it by this column here, right? So 0 by 0 is 0. Minus 1 by 3 is going to give me minus 3, right? So that's the first row of my answer there. Then the next thing I'm going to do, I'm going to take this row and I'm going to multiply it by this column, right? So 1 by 3 is going to be 3. 0 by 0 is 0. So this number here is going to be 3. And then the last thing we're going to do, we're going to take this same row, but now you're going to multiply it by this column here. So 1 by 0 is 0, and then 0 by 3 is going to give me 0, right? So this here represents my combined matrix here. 0 minus 3, 3, 0. Right? Right? So this is your combined matrix, right? And if you want to work out what are the coordinates of the image, so the point that we're starting off with is 5 minus 7, right? What do they call it here? Hold on. Yeah, they just call it a point. Let's call it, so this is 5 minus 7. Right? Now, if you want to find the image, all you need to do is to take the combined matrix, which is 0 minus 3. And this here is 3, 0. And you're going to multiply by that point there. Let's call that point P. And this here is going to be 5 minus 7. Right? When I work out this answer here, I'm going to get that image, which we're going to call P prime. Right? So to work this out, we're going to do our row by column multiplication again. Right? So it's going to be this row multiplied by this column here. So 0 by 5 is 0. 7 minus 7 by minus 3 is going to give me 21. And then for the last one here, it's going to be this row multiplied by this column. So that's going to be 3 by 5 is 15. 0 by minus 7 is 0. So this is going to be 15 here. So therefore, this point here is going to be 21, 15. Right? I know for some of you all, this question is a bit strange, right? I'm hoping that you'll be able to go back to the video itself and see how to answer it, right? Right? So guys, those who really want the help, right, try to focus on what I'm doing, right? This is not an easy topic, right? It's not an easy topic. So try your best to pay attention, right? right? So that takes care of one exam question here, right, on vectors and matrices, right? Let's have a look at a next question here. All right, so this one here, they give us a diagram and it shows two position vectors OA and OB, right? Part A, they want us to write the vector OA in column vector format. So this is O here, right? This is A here. This here is the point B, right? Now let me give you a little hint here, right? Every time CSEC gives us a question like this, what you could do, could you all write down the coordinates for me of A? Could you all write down for me what are the coordinates of A? Right, this one is January 2012, or January 2012. Right, so everybody's telling me it is minus 1, 3, right, minus 1, 3. So check this, right? So some students have a little trouble trying to figure out what are the coordinates. So if A, right, you all telling me it is minus 1, 3, right? If I want to write the column vector OA, all you guys need to do is to write it as minus 1, 3, you know. That's all, right? Nothing fancy, that's it, right? So what about the vector OB then? Could you all tell me what are the coordinates of the point B? Right, everybody's saying 5, 1, right? So great, right? So yes, it's 5, 1, right? So that means that the vector OB here, right, is actually going to be written as 5, 1, right? So let's pray that we get an easy question like this. If they give us a diagram and they want us to write on the column vectors, right, it's as simple as reading of the coordinates. Now part C here, we want to write down what is the vector BE. Now there are two ways we can work this out, right? There are two ways we can work this out. So based on the diagram, I can say that the vector BE, right, is equal to, so I want to go from B to E. That's this direction here. Now, CXC doesn't, they probably don't realize this, but a student could just look at the diagram and they can figure that out, right? They can look at the diagram and see how we can move from B to E. Or we can do it by calculation. B to E is the same as going from B to O plus O to E, right? We can do this as well. So B to O is the opposite direction of OB. Anytime you want to reverse the direction of a vector, just multiply by minus 1. So the vector BO is going to be minus 5 minus 1, right? Plus the vector OE, which in this case is minus 1, 3, right? And when I work this out here, minus 5 plus minus 1, you're going to get minus 6. So this is going to be minus 6. And then minus 1 plus 3, you're going to get 2, right? So my vector BA here is going to be minus 6, 2. That is by calculation. But, let me get a darker color here. You could have also done it like this. If I want to go from B to A, I'm going backwards. 1, 2, 3, 4, 5, 6 to the left. So you should go negative 6. And then you're going to go 1, 2 upwards. So therefore, this is going to be 2, right? So just by looking at the diagram, I could have figured out that the vector is going to be minus 6, 2. Or I can do it by calculation, I'll get the same answer, right? They can't penalize you for whatever method you use. Once you get the same answer, that's all they want to know, right? let's see what else we have in this next question here. All right. So they said, given that G is the midpoint of AB, so we have a point here now. So let's go back to the diagram. So there's a point somewhere inside here, and that's called G, right? That point is called G. And what we want to do, we want to figure out what is BG, right? What is BG? So like I said, diagrams are important when you're working out these things here. So you want to get BG, right? So that's here. Now the thing is, if G is the midpoint of AB, right? It means that BG, to this part A here, so the vector BG is going to be a half, right, of the vector BA, right? BG is a half BA, yeah. Right? So this is going to be a half multiplied by the vector BA, right? But yeah, they made us work out BA. So BA was minus 6, 2. So it's going to be a half by minus 6, 2, right? So that's a scalar multiplication. So what we do, we take a half multiplied by minus 6, you're going to get minus 3. And then a half of 2, you're going to get 1, right? So this is my vector here, minus 3, 1. That's it, right? That's the vector minus 3, 1, right? So that takes care of part A. Part B now, we want to know what is the vector OG, right? So if you go back to the diagram is so important. Can't stress that enough, right? You want to get what is this vector here. This is OG, right? So to get OG, I can go from O to B and then B to G. So OG is equal to O to B and then B to G, right? So OB is equal to 5, 1, right? So OB is 5, 1, right? And BG is what we just worked out there, which is minus 3, 1, right? So 5 plus minus 3, that's the same as saying 5 minus 3, you're going to get 2, and then 1 plus 1, you're going to get 2 as well, right? So the vector OG is given by 2, 2. Let me check something here. Yeah, well, if you notice where I drew this here, that's actually 2, 2. So we're good to go, right? That's correct. Right, let's see what else we have here, right? So this next part here is going to be a matrix part. Right. So here's what we're going to do here, right? So they give us two 2x2 matrices. We have L and M. And the first part, we want to work out L plus 2M, right? So we want to work out L plus 2M, right? So the matrix L is given by 3, 2, 1, 4, right? Plus 2M. So this is a scalar multiplication here. So this is minus 1, 3, 0, 2, right? So what I would do, I'd work this step by step. I'll work out the scalar multiplication first. So this is going to be 3, 2, 1, 4, right? And we're going to add that to 2 by minus 1 is going to give you minus 2, right? 2 by 3 is going to give you 6, 2 by 0 is 0, and 2 by 2 is 4, right? So all I've just done there, I've worked out 2m. That's a scalar multiplication. Next thing we're going to do, we're going to add these two matrices. So we're going to add corresponding elements. So 3 plus minus 2, you're going to get 1. 2 plus 6, you're going to get 8. 1 plus 0, you're going to get 1. And then 4 plus 4, you're going to get 8. Right? So this here represents my matrix L plus 2m, right? Don't get too scared, guys, right? Don't get too scared. We'll do a few examples here and hopefully you'll be able to manage at least something in the exam, right? All right, the next thing that we want to work out here is this matrix multiplication LM, right? This matrix multiplication LM. Now for this one here, I'm just gonna I'm gonna do it in a little more detail because some of you all, right? Some of you all probably haven't even done this in school, right? So I'm gonna go through it in a little more detail, right? So we have L and we have M. Let me just copy this. Hold on. Huh? Right, so those of you who are wondering how we're gonna multiply this here, right? This is what's happening, right? So you want to work out L by M, right? So that is basically taking this matrix 3, 2, 1, 4, and you're multiplying that by minus 1, 3, 0, 2, right? Now guys, pay attention to this, what I'm gonna do here, right? So when you multiply a 2 by 2 matrix, your answer is going to be a 2 by 2 matrix, right? Now, what you need to remember when it comes to these multiplications is that you're going to multiply. So to get this first number here, you're going to take this row and you're going to multiply it by this column here, right? Now, here's what you're actually doing. You're taking 3 multiplied by minus 1, right? And then you're adding that to 2 multiplied by 0. So 3 by minus 1, you're going to get minus 3, plus 2 by 0 is going to give you 0. So this is going to be minus 3. So the first number that I'm going to put here, right, in that matrix is going to be minus 3, right? So this first number here is going to be minus 3. That's the first number inside here. Next thing we're going to do, we're going to take the same row here, and you're going to multiply it by this column here. So that's going to be 3 multiplied by 3 plus 2 multiplied by 2. So that's going to be 3 3s are 9 plus 2 2s are 4. That's 13. So this number here is going to be 13. That's where I'm getting that from, right? So now we need to figure out the last row in the matrix here. So what we're going to do, let's use a different color here. So now we're going to take this second row here and you're going to multiply it by this column here. So this is going to be 1 by minus 1 plus 4 by 0, right? So 1 by minus 1 is going to give you minus 1, 4 by 0 is going to give you 0, right? So this is going to be minus 1, right? So this number here is going to be minus 1. And then to work out the last number in the matrix, it's going to be this row multiplied by this column here. So that's going to be 1 multiplied by 3 plus 4 multiplied by 2. So this is going to be 3 plus 4 2s are 8. So this is going to be 11. So this is going to be 11. So it's minus 3, 13, minus 1, 11. Right? So that's your matrix multiplication there. Right? I see some of you all keep asking about chemistry and physics and admats. If I do have time, right? If I do have time, I will probably do something, right? But I can't guarantee anything. Right, so that's my 2 by 2 matrix here, right? Moving on to the next one. So we have a matrix Q, and we want to work out this first part here is the inverse of the matrix, right? So the first thing we need to do, we need to find what is the determinant of Q, right? So the determinant of Q, we have to take this number and multiply by this number. So it's going to be 4 multiplied by 1 minus, then we have to take this number and multiply by this number here. So that's going to be 2 multiplied by 1. That's how we find the determinant of a matrix. So this is going to be 4 by 1 is 4 minus 2 by 1 is 2. So your determinant is going to be 2, right? Now the inverse matrix, guys, right, which is written like this, is equal to 1 over your determinant, which is 1 over 2, multiplied by what we call the adjoint of the matrix. Now, if I were to take this matrix here and I want to write what we call the adjoint of the matrix, what you need to do, you need to swap the positions of the 4 and the 1. So you're going to put 1 here and you're going to put 4 here. And you're going to put a minus sign in front of the 2. And you're going to put a minus sign in front of the 1. So this here is what we call the adjoint of the matrix. So it's going to be 1 over the inverse multiplied by 1 minus 2 minus 1, 4. Right? Now, for a question like this where they ask us the inverse, you can leave your answer like this if you want, right? Or what some students do, they write it out like this. A half minus 1 minus a half, 2, right? So you can put any one of these in order to get your mark for the inverse of the matrix, right? Right, so that's the inverse of my matrix here. Now, part 2 of the question here says, using the matrix method, find the values of x and y in the equation. Now, basically what we're doing in this part of the question here, we are doing a pair of simultaneous equations. So this same question could have been written like this. 4x plus 2y is equal to 8, and x plus y is equal to 3. So CSEC could have told us to solve this pair of simultaneous equations, but the first step we would have had to do is to write it so that it looks like what we have here, right? So they kind of bypass a step, right? They didn't tell you we have a pair of simultaneous equations, but what they told us is, here what? We have this equation here, and we're trying to figure out what x is, right? So all I'm going to do, let me, hold on here. So this is what we have, and this is what we're trying to solve, right? So this is one of those scenarios where we are going to use the matrix method to figure out x and y, right? Now, this matrix here, you already worked out what the inverse is, right? They told us to work out that inverse. So if you want to solve a question like this, what we're going to do is to multiply both left and right of the equation by the matrix, right? The inverse of the matrix. Now, I'm going to give you a little piece of advice here. And this is what I tell my class to do, right? So when you're trying to do this multiplication, my suggestion to you is to use the inverse in this format here, not the second one here, right? Because you're going to end up in a scenario with a lot of fractions, which you really don't want, right? So if you're working out a simultaneous equation, try to use it in this format here, right? The inverse, that is. So I'm going to use it in that format. I'm going to multiply both sides of the equation by the inverse matrix. So in this case here, it's going to be a half 1 minus 2 minus 1. So it's going to be a half, right? 1 minus 2. Right, I just trying to make sure I have the correct thing here, right? Minus 1, 4. Right, so that was the inverse. So you're going to multiply the entire left-hand side of the equation by the inverse. Right, but on the right-hand side, you have to be careful. You have to write that matrix first. Right, so it's going to be 1 minus 2 minus 1, 4 multiplied by 8, 3. Right. So I know it looks very complicated. I know that it looks very complicated, right? But in a case like this, what you need to do is to ensure, now let's not make sure I have the correct thing here. 1 minus 2 minus 1, 4. Right, yeah. And I get this question a lot here, right? So what did you just do here? So the only difference between the first line, this line, right, and the second line here, the only difference is this. You will notice that I have included this here, right? And remember, this here was the inverse of the matrix, right? This was the inverse of the matrix. So what I did in this line here is to multiply left and right by the inverse. Now the left-hand side looks very complicated, and I'm going to show you what happens on the left-hand side here. When I take a matrix and I multiply by its inverse, I'm going to get my identity matrix, right? So that's going to be an identity matrix. When I take an identity matrix and I multiply it by any matrix, I'm going to get back that same matrix, right? So those of you who might be familiar what I'm talking about, if I take a matrix and I multiply by the inverse, I get what we call the identity matrix, right? That's one rule for identities. Also, if I take the identity matrix and I multiply by any matrix, I'm going to get that same matrix back. If I take the matrix and multiply by the identity, I will also get that same matrix back. So these are three important rules regarding identity matrices, right? And those of you who are not sure what the identity matrix is, it is this. Identity matrix is given by 1, 0, 0, 1, right? That's what we call the identity matrix. So on the left-hand side of my equation, everything is going to disappear and you're just going to end up with xy. No need to write anything else. That's it, right? On the right-hand side now, just leave the half on the outside, and all you're going to do a matrix multiplication there, right? To do that multiplication, what I'm going to do my row by column. So we're going to take this row and multiply by this column here. So I'm going to work this one out in my head, right? So 8, 1 by 8 is 8, minus 2 by 3 is minus 6. So therefore 8 minus 6 is going to give me 2, right? So that's the number on top here. Then we're going to take this row and we're going to multiply by this column here. So minus 1 by 8 is going to give you minus 8. 4 by 3 is 12. So minus 8 plus 12, you're going to get 4. So now the final line or the final step is going to figure out what is x and y. So therefore xy, right, a half by 2 is going to give you 1, and a half by 4 is going to give you 2. So what that means is that x is equal to 1 and y is equal to 2. Right? Some people are asking about the identity matrix on the left side. Yeah, you don't need to write it, right? You don't need to write it, right? Right? So let's see. So we do our next one here. Right, so we have our next one here. This is January 2011, right? January 2011. All right, let's see what we have here. So we have OP and OR are position vectors, right, with respect to the origin O. The point P is 2, 7 and PR is 4, 3, right? Now, for me, if I have to do a question like this, I need to see what's happening, right? I need to see what's happening. So the point P is 2, 7, right? And PR is 4 minus 3. So the point P is 2, 7. So 2, 7 could be somewhere here. So we can call that point P, right? This is O. right? Right? So P is 2, 7, right? And PR is 4 minus 3. Now, 4 minus 3, this is a vector here, right? And it's PR. So that means that if it's 4 minus 3, you're going 4 across, right? And then you're going 3 down, right? So therefore, this here is going to be where R is, right? Now, this is just for me to visualize what's happening. Eh? That's all it's for, right? So that's PR. So we want to figure out what is the vector OP. So part A, they want to know what is the vector OP in column vector format. So all we need to do is to use the coordinate here. So this is going to be 2, 7. That's it, right? That's going to be the answer for OP. Next thing we want to get OR, right? So if you want to get a vector OR, right? Now, based on the diagram there, I can get OR by going from O to P and then P to R, right? So OR is OP plus PR. Now the vector OP, we just wrote it down as 2, 7, right? And then we're going to add PR, which we know is 4 minus 3. So therefore, this is going to be 6. 4 and 2 is 6. 7 minus 3 is going to give me 4. So this here represents my vector OR, right? That's vector OR. I hope that making sense for you guys, eh? Hope so. Right, the next part here now, they set a point S, right? A point S has coordinate 14 minus 2, right? 14 minus 2, find RS, right? So S is somewhere down here, right? S is somewhere down here, right? And they're telling us that they want us to find the vector RS, right? Now, the point S is 14 minus 2. So therefore, OS in column vector format is going to be 14 minus 2. Right? This is our vector here for OS. Right? Now, I want to figure out the vector RS. So check this. If I want to get RS, RS could be RO, right? Plus OS. Right? So the vector, let's see. RS is equal to RO plus OS, right? Now, some of these things you can do to out the diagram, eh? But what I needed to pay attention to is this. This is the vector we want to get, RS. So that's your start point and that's your end point. What I want you to pay attention to is that in your vector equation, on the right-hand side, you will notice you start at the same R and you end up at the same S. Now you can always know if you have the wrong equation because you must always start at the same R in this case here and you must end up at S, right? And you see these two letters here? These two letters here needs to be the same. If you notice you write a vector equation and you realize those two letters are different, then something is wrong, right? You're definitely doing something wrong, right? So RO in this case here, it's the reverse of this vector here, right? So it's the reverse of this vector here. So it's going to be minus 6 minus 4. Right? Plus the vector OS, which we know they told us it there. It's 14 minus 2. Right? So minus 6 plus 14 is going to give me positive 8. And then minus 4 plus minus 2, you're going to get minus 6. Right? So that's my vector RS here. Right, that's the vector RS. So that takes care of this, right? And the next thing here, they want to show that PR and S are collinear, right? So I remember in Form 5 seeing this word and I really had no clue what they're talking about here, right? But what they mean is that whenever things are collinear, it means that they all lie on the same straight line. So based on the diagram that we have here, right? Based on the diagram that we have here, we have P, R, and S, and all of them lying on the same straight line. Now, a lot of students, they're not sure how to answer this particular question. And the other problem is that even if they try to answer it, they're not given what is required in order to answer the question, right? Now, to answer this question here, we need to look and see what vectors we do have. Now, let me use a clean page to show you this, right? Hold on. Right? So I'm just going to draw something here, right? So far we know that we have something looking like this, right? And the lines, let me see something here. It's PRS, right? So we have P, we have R, and we have S, right? And we need to somehow prove that these 3 points are collinear, that they all lie in the same straight line. Now if we look to see what vectors we actually have, so we have the vector RS, right? So we know what this vector is here, right? What else we have? Do we have PR or anything like that? We have OP, we have OR, and we have R. Okay, so here's what I would do, right? Right. So whenever you have to prove that vectors are collinear, right, you have options. What you can do is to find the vector PS, right, and compare PS with, let's say, RS, right, as one possible way of proving that they are collinear, right? We can also find PR, right, and compare that with RS. That's another way of proving that they are collinear, right? So they have options. Right? So what I normally do, I normally start with the longest vector, right, and a vector in between, right? So I would probably use, actually wait, no, I won't use that one because I don't have a common, do I have a common point? Yeah, we have a common point here. So I'll probably use this one here, right? I'll probably use this point here. So let me explain how I will do a question like this. So I already know what RS is. We worked that out before, right? That was the last thing we worked out. We got RS as being 8 minus 6. So write down that vector, 8 minus 6, right? And what I'm going to do now, I'm going to figure out what is PS. So if I don't have it, I'm going to work it out, right? So PS, and I don't even need a diagram for this. PS is equal to PO plus OS, right? So once I know how to write a vector equation, you're starting at P, you're ending at S. So therefore, on my right-hand side, I must start at P, end at S, and these 2 letters need to be the same, right? So PO, let's go back to our diagram. PO is going to be -2, -7. Yeah. PO is -2, -7, right? And you're adding that to OS, which was some big number. OS is 14 minus 2. Right? So minus 2 plus 14, you're going to get positive 12. And then minus 7 minus 2, you're going to get minus 9. Right? So now I have RS and I have PS. Right? If I want to prove that 2 vectors, or if I want to prove that points are collinear, there are 2 things I need to show. I need to show, right, there are 2 things that CSEC is looking for. One, right, that the 2 vectors that I have there, they must be parallel, right? And the second thing is that we must show that we have a common point. Those are the 2 things CSEC wants us to put in order to answer this question, right? We need to prove that these 2 vectors are parallel and they have a common point. Now the 2 vectors I have chosen is RS and PS, right? So clearly they have a common point. The common point in my case here is going to be S, right? Because each vector has an S in it. But what I need to do, if I want to show that vectors are parallel, I need to prove that one vector is a scalar multiple of the other vector, right? Now this is the part that's be a little tricky for some students. So all I'm going to do here, so PS, right? PS should actually be equal to, so P is the longer vector, right? P is the bigger vector. So all I need to do is to prove that PS is equal to K multiplied by RS, where K is a constant that we need to figure out. Once you figure out this constant here, I'm going to prove that it's parallel, right? So the vector PS is 12, 9, right? Is equal to K, right? Multiplied by RS, which is 8 minus 6, right? This is a minus 9 here, right? So could anybody tell me what K is by the way? Could anybody tell me what is K? For those of you following, could you tell me what K is? Right, so I've seen people getting 1.5. So this is one of those things where students have difficulty with it. So what I'm going to do, I'm going to figure out what K is, right? And all I need to do here, right? I know some people might just be guessing or trying to, all you need to do here, you can see that 12 is equal to K multiplied by 8, sorry, right? So therefore K is equal to 12 over 8, right? So that's going to be 1.5, or it's going to be 3 over 2, right? So that's my key. So I can use the top piece here to work out key, or I can use the bottom piece and I'll get the same value for key. So therefore, what I'm saying is that 12 minus 9, right, is equal to 3 over 2 multiplied by 8 minus 6, right? So that means that the vector PS is equal to 3 over 2 multiplied by RS, right? And this is what we're trying to do here. Once you end up with a situation like that, you've actually proven that the vectors are parallel, right? Now, here's what you need to say in order to get your mark, right? This is what you need to say. Well, just carefully here, because lots of students, they don't know exactly what to say in order to get a mark, right? All you need to say here, based on what we just worked out, we can say, right? So remember, we have PS is 3 over 2 RS. So PS is 3 over 2 RS, right? So here's what you're going to say. There are two things we need to say to get the mark, right? So we're going to say since, right, PS, write a little better, is a scalar multiple of RS, right? So, and I'm saying that because of the statement that we have here, right? So this is, we're gonna mark for this. Since PS is a scalar multiple of RS, they are parallel. Right? And the next thing we need to say is that since, right, PS and RS have a common point, right? The common point that we have here is S, right? It means that P, right, R, and S are collinear, right? That's what we need to say. Right? So I want you all to understand how they actually mark this in the exam. There are two things they're looking for. One mark for saying that the vectors are parallel, and the second mark is for saying that there's a point in common, right? So the reason why they are parallel is because one is a scalar multiple of the other, right? So we showed that PS is 3 over 2 RS, and we also showed that based on the vectors we have there, we have a common point of S. So that means they are collinear, right? So you have to be careful how you're answering these questions, right? PR and RS, yeah, you can use PR and RS, right? You could use PR and RS if you want, right? And once you get a scalar, a value for key, right? Right? That's fine. Right? I'm gonna do a next one here, right? I'm gonna do a next one here. So we have a figure here, not drawn to scale, but it shows a parallelogram, right? And they're given some vectors here. We have DC is 3x and DA is 3y. Whenever CSEC gives us a parallelogram, I want you all to write in what some of these vectors are one time. So this here has to be 3x, and this here has to be 3y, right? So putting those vectors one time, because it's a parallelogram, so therefore certain vectors are going to be similar. So if this is 3y, then this has to be 3y. If this is 3x, then this has to be 3x, right? It's a parallelogram. They're telling us that a point P, so we have a point P here, and the point P is such that DP to PB is 1 to 2. So you have to ask yourself, how many parts, right? Let me ask you all a question. How many parts am I going to divide the line DB into? How many parts am I going to divide the line DB into? Right? So there are too many messages, so I can't really monitor the chat too much, right? Right? So people saying 3 parts. Yeah, I agree, right? Those are the thought processes that need to go on in your head, right? So DB has to be divided into 3 equal parts, right? So let's start. If I want to get the vector AB, right? My vector equation is going to be this. AB, according to the diagram, right, is, oh, we don't need to do anything. AB is actually simply going to be 3x, right? That's the answer for this one here. BD, so BD on the other hand, we can write a vector equation for that. So BD, right, according to the diagram, I can go from B to A, right, and then from A to D, right? That's one possible route I can take. So if I want to go from B to A, that's in the reverse direction, so that's going to be minus 3x plus the vector AD, which is going to be negative 3y, right? This is going to be negative 3y. I'm going in the opposite direction, right? So the vector BD is actually minus 3x minus 3y, right? That's the vector BD. So that's the answer for part 2. For part 3 now, we want the vector dp, right? So dp, right, is equal to, right, 1/3, right, of the vector db, right? Because we just divided up the line into 3 equal parts. So therefore, if I want dp, it's going to be 1/3 db, right? So this is going to be 1/3. Now the vector db is the reverse direction of this, right? So that's going to be 3x plus 3y, right? You're reversing the direction. So when I work this out here, I'm going to get x plus y, right? So that is the vector dp, right? It's going to be x plus y. All right, just give me a sec here. I just need to clean up this chart here, right? All right, I just do some cleanup here, guys. Hold on a sec, all right? Right, so we had to do work, and that's it. That's all we're here for, right? So any other side chart here, I'm gonna knock you guys out, right? All right, so let me move. Let's do our next piece here. So that was dp, right? All right, now we want to show that ap is x minus 2y, right? We want to show that ap is x minus 2y, right? Let me see something here. Right, so this is AP here, right? So go to the diagram, and this is AP here, right? So AP, based on our diagram here, we can work out, let's see, we have DP. So what I would do, if I want to get AP, I'd go this way. That's A to D, and then D to P, right? Because I already have that here. I have this here. So let's see if that's really true. Right, so we want to get AP. So according to my diagram, AP, right, is equal to, let's go back here, AD plus DP. Right, now AD, let's go back here, AD is minus 3y plus dp. We just worked out dp there. We got x plus y. Right, so when I work this out here, this is going to be x minus 3y plus y is going to be minus 2y. Right, let's hope that was the correct answer. Yeah. So we got the same answer here, x minus 2y. And this part here, we have a proof again, right? So E is the midpoint of DC. So let's go back to that diagram there. E is the midpoint of DC. So that's here, right? So we have a point E here. And what we're trying to do, we're trying to prove that this point here, E, A, and P are collinear, right? So we have a next collinear problem here, right? And if you notice, they're giving you plenty marks for this here in this particular exam. In your exam, they might just give you maybe 3 marks. They could probably give you 4, I guess. All right, so you want to prove that A, P, and E are collinear, right? So you had A here, right? P, right? And we have E here, right? So again, you have to make a decision. You have to decide, all right, what vectors do I need in order to prove these things are collinear? So you can use AP and PE if you want, right? You can use AE, right? And AP if you want, right? So it depends. You could decide whatever you want to prove, right? Or whatever you want to show. So I would normally choose based on what I know, right? If I go back to the vectors that I do know, I know AP, right? I know the vector AP, right? I know the vector AP. So for me, what I would probably do, I'll work out the vector AE as well, right? So I would use this route here as my method to prove that they're collinear, right? So look at this. Let's see how we're going to do this. I have AE already. That's this vector here. So the only other vector that I need to find now, I should find what AP is, right? I have AP, my bad, and I need to figure out what AE is, right? Let me find out what AE is. So AE, right? And you can look at your diagram to figure out AE. So AE is the same as going from A to D and then D to E. So it's going to be A to D, right? A to D and then D to E, right? So those are, that's how I'm going to get to this, right? Now the vector AD, I know what it is, right? Now the vector DE, let's back up a sec here. What is DE, right? Now DE, remember E is the midpoint of DC. So therefore DE is going to be a half DC. So DE is going to be a half DC, right? So AD is, go back to the diagram, AD is going to be minus 3y, right? Plus a half multiplied by DC. What is DC? Right, so a half DC will be a half by 3x. Right, so this is going to be minus 3y plus 3 over 2x, right? But I want to write this so that x is first and y is after. So this is going to be 3 over 2x, right, minus 3y, right? So now I have my two vectors here, right? I have my AP and my AE, right? So therefore, in terms of the location, this is A, this is P, and this is E here, right? And again, I'm going to try to prove that they are collinear, right? There are two things we need to prove. The first one is to show that AP and AE are parallel. In order to do that, I need to show that one vector is a scalar multiple of the other vector. So let me start over the vector AE. So AE is the longer vector. So AE is equal to K times P, right? That's what we know. Now AE is 3 over 2x minus 3y. Right? And this is K here. And you're multiplying that by the vector PE. No, sorry, wait, hold on. My bad. We're looking at AP and AE. Alright? So this is AP here. That's all. So it's AP we're working with here, right? So the vector AP, we knew that as being x minus 2y. Could anybody tell me what is k equal to? What you all think k is equal to? Right? What are you all getting for k, right? Right? So I've seen a lot of people getting 1.5 or 3 over 2. Yeah. So what you all need to do, you need to look at this and realize, well, you know what? K in this case here is actually 3 over 2. Right? That's what k is. Because if I take 3 over 2 and I multiply by x, I'm going to get 3 over 2x. If I take this k and I multiply by negative 2y, right, you are going to get negative 3y. So therefore, what we're going to say here, we're going to say AE, right, is equal to k, right, times AP. Oh, sorry, let's put in what k is, my bad, right, equal to 3 over 2, right, AP, right? So once I have this here, guys, right, I have already proven that the two vectors are parallel. Once you are able to show that one vector is a scalar multiple of the other, right, it means that the vectors are parallel. So here's how we're going to answer the question, right? Remember, it's a 2 mark here, 2 marks we're going to get for this piece here. So you're going to say since, right, AE, right, is a scalar multiple right, of AP, right? And I know that because of this statement here. That's what I know that because of that statement, right? So since AE is a scalar multiple of AP, they are parallel. Right? And then we're going to say since, so this is the second mark here now. So since, right, AE, right, and AP have a common point, right, and the common point in this here is A, right, it means that A, P, and E are collinear. Right? So, like I said, make sure if you have to answer, prove that two things are collinear, these are the two things CXC looking for. They're looking for this statement and they're looking for this statement. If you don't have that statement, then you're not proving that they're collinear. Right? Right? Alright guys, so this is as much time as I have for this afternoon, right? So at least you got to view some vector questions and 1 or 2 matrices questions here, all right? All right guys, so that's it for me for this afternoon. I hope that you picked up something at least, right? I hope you picked up something at least, right? Um, so the next few sessions, I still have to do investigation type questions, right? I still need to run through geometry and trigonometry, right? And we still need to do some graphs, right? So guys, enjoy the rest of your afternoon. Be safe. Good luck with your studying, right? Good luck with your studying, and I will see you guys next week, Wednesday, right?